Okay, here's another type of equation that we're going to learn how to solve. This is called an absolute value equation because of the absolute value bars around the 2x minus 3 here. So in order to solve an absolute value equation, the first thing you have to do is isolate the term inside of the absolute value bars. So in this case, we're going to subtract 2 from both sides, giving us the absolute value of 2x minus 3 equals 5. So the absolute value term is isolated. It's alone on one side of the equal sign. So now what this is saying to us is 2x minus 3 can be 5, or 2x minus 3 can be negative 5. Just recall what an absolute value means. The absolute value is the distance from 0. So that's saying after we evaluate this term, we take the absolute value of it, and it's 5. Well, the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So what this is saying is that the inside of this is either 5 or negative 5. So that's exactly what we're going to do. We're going to break it up and solve two different equations. So as soon as the absolute value bar is isolated, whatever's on the other side, make it positive and make it negative and solve them both. And that'll drop the absolute value bars for you. So the inside is equal to positive 5, and the inside is equal to negative 5. So we're going to get two solutions for this. Add 3 to both sides. 2x equals 8. X equals 4. In this case, add 3 to both sides. 2x equals negative 2. And divide by 2. X equals negative 1. So there are our two solutions. So just to review, step 1, isolate the absolute value bar. Step 2, make the inside equal to the positive value over here, and make the inside equal to the negative value over here, and then solve separately. Here's another example. Now take a look at this. Now we have a variable on the outside. That's going to pose some challenges when we get our solutions. Now the absolute value bar is already isolated. It's already alone on one side of the equal sign. So we're just going to make the other side of the equal sign positive and negative. So 3x plus 1, the inside, is equal to the positive value, x plus 5. And 3x plus 1 is also equal to the negative value, negative x plus 5. Notice my use of parentheses here, saying that the whole side of the equal sign is negative. So the inside is equal to the positive value, and the inside is equal to the negative value. But because it's a binomial, I had to use parentheses to remind myself to distribute that negative. Well, this side's ready to be solved. 2x plus 1 equals 5. 2x equals 4. So we get x equals 2 over here. This side, let's distribute the negative. 3x plus 1 equals negative x minus 5. Now let's add x to both sides. 4x plus 1 equals negative 5. Subtract 1 from both sides. 4x equals negative 6. Divide by 4. X equals negative 6 over 4. Or reduce to negative 3 over 2. Now, anytime you have a variable on the outside, we're going to have to check and plug back in to see what we get. We have to check our answers. So if we plug in 2 to the original equation, I'm going to plug it into this original equation up here. This is my check. The absolute value of 3 times 2 plus 1 is equal to, and now there's two x's to plug into, here and here, is equal to, we're plugging in x equals 2, 2 plus 5. The absolute value of 6 plus 1 is 7. Is equal to 7. Yes, it sure is. So this is a solution. This side, let's check that out. So the check for here, we're plugging in negative 3 over 2. The absolute value of 3 times negative 3 over 2 plus 1 is equal to negative 3 over 2 plus 5. Alright, so this is going to take a little work, so we need a common denominator over here. This is just like 3 over 1. Let's multiply across the numerator. Negative 9 over 2 plus, and I'm not going to say 1, I'm going to say 2 over 2 is equal to negative 3 over 2, and I need a denominator of 2, so I'm going to multiply this term by 2 over 2 to get that, giving me 10 over 2. So this gives me the absolute value of negative 7 over 2 is equal to 7 over 2. So, worked out. They may not. If you get a false statement in the end, you're going to reject that solution. In this case, we're going to accept both of them. Alright, so that is an elementary example, an intermediate example, and now I'm going to go through a difficult example. Now, in this case, the absolute value bar is not isolated, so I need to subtract 2x from both sides. Now the absolute value bar is isolated. So we're going to break it up into two separate equations. We're going to make the inside equal to the positive value, or left alone rather. X equals negative 2 minus 2x. And we're going to make it equal to the negative value. Note my use of parentheses to remind myself to distribute the negative. Okay, let's add 2x to both sides here, giving us 3x equals negative 2. Divide by 3. X equals negative 2 over 3. I'm not going to box it yet because I need to check these solutions. Let's distribute the negative. X equals positive 2 plus 2x. And now I can subtract 2x from both sides, giving me negative x equals 2. Divide by negative 1. X equals negative 2. I'm going to plug in this side first just because it looks a little easier to work with. 2 times, this is my check, negative 2 plus, and I'm plugging into the original again, the absolute value of x equals negative 2. Negative 4 plus, well, the absolute value of 2 is 2, equals negative 2, and you get negative 2 equals negative 2. Good to go. Oh, that's not the solution, this is. Put a box around it. Oh, no eraser. Alright, so now we're going to plug in this side, but we got a fraction here, so it's going to be a little more difficult. Not impossible, just a little more challenging. And we're plugging this into the original solution. Here's my check. 2 times x, which is possibly negative 2 over 3, plus the absolute value of x, which is perhaps negative 2 over 3, equals 2. So 2 times negative 2 is negative 4 over 3, plus the absolute value of negative 2 over 3 is positive 2 over 3, equals negative 2. Well, we don't know. Does it equal? We'll see. It's a question mark. Negative 4 thirds plus 2 thirds is negative 2 thirds. Does that equal negative 2? No, it doesn't. So we will reject this solution. So our only solution is x equals negative 2.